In today's video, we will be learning some more criteria for congruence of triangles, which is part 7.5 in chapter 7 triangles of class 9 math CBSE. We'll also be doing exercise 7.3 questions. In 7.1 to 7.3, we had learned different congruence criteria such as side angle side angle and angle side. In today's video, we'll also cover two more criteria for congruence of triangles. The first one is SSS congruence rule, which is if three sides of one triangle are equal to three sides of another triangle, then the two triangles are congruent. Let us take a look at this picture over here, which has two triangles ABC and PQR. Corresponding sides AB and PQ, AC and PR, and BC and QR are equal to each other. That means these triangles are congruent to each other. The next criteria is RHS congruence rule. This applies to right angle triangles. It is said that if in two right angle triangles, the hypotenuse and one side of the triangle are equal to the hypotenuse and one side of the other triangle, the two triangles are congruent. That can be represented in a picture over here. Again, let's say this triangle is ABC and this triangle is PQR. In this triangle, both triangles have 90 degrees angle, so they are right angle triangles, and hypotenuse AC is equal to hypotenuse PR, and another side, that is AB, is equal to PQ. Here we say these two triangles are congruent according to RHS congruence rule. If you remember, in side angle side, we discussed that side angle is not a valid criteria for congruence. So this also looks like side angle. However, with an exception of right angle triangles where it is valid, and we call it RHS congruence rule. Let's start solving exercise 7.3 questions. First question says triangle ABC and triangle DBC are two isosceles on the same base BC and vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, show that triangle ABD is congruent to triangle ACD and triangle ABP is congruent to triangle ACP, and also show that AP bisects angle A and angle D and AP is also a perpendicular bisector of BC. Let's start solving this question. Writing down the given information, I know that AB and AC are equal as given to me, and BD and CD are also equal. So this side is equal to this side and this side is equal to this side. Now first question says to prove triangle ABD and triangle ACD are congruent. So ABD and triangle ACD. I have drawn these triangles here. So I can see that AD and AD are common side over here. So from side congruency rule, because all the sides are equal, I can say triangle ABD is congruent to triangle ACD. Hence we have proved the first part of the question. In the second part, we are asked to prove that triangle ABP is congruent to triangle ACP. I have drawn these two triangles here. From the given, I know that AB and AC are similar. What we just proved was triangle ABD is congruent to triangle ACD. So from this, I know that angle A here and angle A here will be equal, which is nothing but angle BAP and angle PAC. So these two angles are equal, and here I know that AP and AP is the common side, so that is equal. I can use SAS congruency rule to say that triangle ABP is congruent to triangle ACP. In the third part of the first question, we are asked to show that AP bisects angle A and D. So this is AP. We need to show that it bisects angle A, that means this angle should be equal to this, and it bisects angle D, that means this angle over here should be equal to this angle over here. So from 1 and 2, we have proved that triangle ABD is congruent to triangle ACD and triangle ABP is congruent to triangle ACP. So from this, I know that BAP and PAC are same. So this AP is bisecting angle A. We have proved this part. Now for angle P, I know that angle ADB equals to angle ADC, because this angle and this angle will be equal if these two triangles are congruent. So that's what I've written down. Now for this whole angle, I can write angle ADB as 180 minus BDP and angle ADC as 180 minus BDC, because this is a straight line and the whole angle should be 180 degrees on both sides. That's what I have written here. Now from this, I can cancel 180 and I'm left with BDP equals to PDC. So this angle is equal to this angle. That means AP is also bisecting angle D. Fourth question says, show that AP is the perpendicular bisector of BC. Now, from the second part, I know that BP equals to PC because I have proven these two triangles are congruent. I know that this side and this side are equal. That means AP is bisecting PC. But we need to show that it's a perpendicular bisector. That means I need to show that this angle and this angle are 90 degrees. How to do that? Let's consider triangle BDP and triangle DPC as shown here. Now from this, I can say that angle BDP equal to angle PDC from the third question that we have proved, and DB equals to DC, that is this side is equal to this side. So now DP is also equal to DP. From side congruency, I can say that triangle DBP is congruent to triangle CDP. From this I can say that this angle and this angle are equal because these two triangles are congruent. Now these two angles are on a straight line, they are forming a straight line, that means they should be equal to 180 degrees. So I can write as BPD plus CPD equals to 180 degrees. Now instead of writing BPD plus CPD, I can write 2 into BPD because angle BPD and CPD are equal. So 2 into angle BPD is 180 degrees. 2 ones are 2, 90s are. So angle BPD is 90 degrees, which is also equal to angle CPD. So these two angles are proven to be 90 degrees each, which means that AP is the perpendicular bisector of BC. Second question says, AD is an altitude of an isosceles triangle ABC in which AB equals to AC. Show that AD bisects BC and AD bisects angle A. So we have to show that these two sides and these two angles are equal. Writing down the given information, I know that AB is equal to AC and angle ADB, that is this angle, and angle ADC, this angle, are both 90 degrees. Because AD is the altitude, it has to form 90 degrees. Now in triangle ADB and ADC, taking these two triangles over here, I can say that AD is the common side. Already I know that AB equals to AC and I know that this angle is 90 degrees. So from RHS congruency rule, I have a right angle, I have a hypotenuse that is equal and also sides that are equal. So I can use this to say ADB is congruent to ADC. From this common parts of congruent triangles, I can say BD and CD are equal. That means AD bisects BC. I can also say angle DAB and angle DAC are also equal. That means AD is bisecting angle A as well. Third question says two sides AB and BC and median AM of one triangle ABC are respectively equal to PQ, QR and median PN of triangle PQR. I need to show that triangle ABM is congruent to triangle PQN, triangle ABC is congruent to triangle PQR. So first let's write down the given information. AB equals to PQ, AM equals to PN and BM equals to QN. Now I also know that BM equals to MC and QN equals to NR because AM and PN are the medians. So I can say that triangle ABM and triangle PQN are congruent from side congruency rule. So the first part is proven. Now for the second part, consider triangle ABC and PQR. Here I know that AB equals to PQ and ABC equals to PQR because we have proven these two triangles are congruent. So I know that the corresponding angles B and Q should also be equal. So I can write that. Now here BM equals to MC, right? So this half and this half are equal. So I can write BC as 2BM and QN equals to NR. So I can write QR as 2QN. So this would be 2BM and this would be 2QN. However, I know that BM equals to QN. So I can write BC equals to QR. So this side is also equal to this side. From side angle side congruency rule, I can prove that triangle ABC is congruent to triangle PQR. Let's take a look at the fourth question, which says BE and CF are two equal altitudes of a triangle ABC. Using RHS congruence rule, prove that triangle ABC is isosceles. So I have to prove that this big triangle IABC is isosceles. Given to me is that BE is equal to CF and BEC and CFB. These two angles are 90 degrees because they are the altitudes. And now considering triangle BEC and triangle CBF, here I know that BC and BC are the common sides, so I can say this side and this side are equal. So I know that BE equals to CF. These are both right angle triangles. So from RHS congruency rule, one right angle, one hypotenuse and one side are equal. So I can say BEC is congruent to CBF. So I can say BEC is congruent to CFB. So from here I can say that angle B equals to angle C from CPCT. Now using this I can prove that triangle ABC is isosceles. Let's see how to do that. Consider triangle ABC. Here angle B equals to angle C. Now if angle B equals to angle C, then sides opposite to the equal angles should be equal, that is AB should be equal to AC. If two sides are equal, that means ABC is an isosceles triangle. Fifth question says ABC is an isosceles triangle with AB equals to AC. Draw AP perpendicular to BC and show that angle B equals to angle C. Now given to me is that AB is equal to AC and angle APB and angle APC both are 90 degrees. Now I will take these two triangles APB and APC and draw them over here. I know that AB and AC are equal. This is both right angle and these two sides are equal. So from RHS congruency rule, I can say that one right angle, one hypotenuse and one side are equal. So APB is congruent to triangle APC. From this, I can say CPCT angle B equals to angle C. So from common parts of congruent triangles, I can say angle B here is equal to angle C because these two triangles are congruent. With this, we have come to an end to chapter 7 triangles.